I am.
Cool.
Okay, so we should be live now.
Okay, cool. So hi everyone. Today's talk is about Semgrep, an open source tool for finding patterns within source code repositories. It was developed by R2C, or Return to Code. Semgrep, an open source tool for finding patterns with a security startup that focused on integrating security into CI/CD pipelines. So yeah, a little bit confused about the audio feedback right now, sorry. So I'm very happy that Luke O'Malley offered his talk. So he's the co-founder and I think now head of product at R2C. So very looking forward to the talk. And with that out of the way, Lucas has always switched on Luke's screen, so enjoy the show.
Awesome, thank you so much. And hello everybody. I'm very excited to be here and presenting to you all. As you have questions throughout the presentation, I've got my comment screen up, so I'll try to answer those as we go along. Most of the presentation will just be a live demonstration of Semgrep. So my goal is by the end of it, everybody is basically able to use Semgrep on their own. And yeah, I guess let's kick it off. So just to start, my name is Luke. I'm one of the founders of R2C. I studied computer science at MIT in my undergrad and previously worked at Palantir. So I started my career as a software engineer, and I'll joke that I'm a recovering software engineer because I've gone to the dark side of product management. And throughout my career, I built tools for other software engineers. So I just got hooked on developer tooling and then a focus on security. And R2C is we're about a 20-person startup now. So we're based out of San Francisco. We've got folks working all over the world though. And we do static analysis every day, all day. And we're on a mission to profoundly improve software security and reliability. So as software becomes the foundation of our society, we think this is more and more important. So for those who just want to know what's up front and decide if you want to watch this presentation or not, over the course of the presentation, we're going to talk about how it is very easy to write insecure code. Unfortunately, it's just too easy. So how do we kind of solve that problem? And my philosophy and the philosophy of the folks that I work with at R2C is that we should be pushing developers onto what we call a paved road. So there are a set of frameworks that are default safe. And our goal really as a security team is not only to make sure that there are not security issues in our code, but that it's unlikely that there will be future security issues in our code. So a really good example of this, I think, is the React framework, which has dramatically reduced cross-site scripting. So in React, you can dangerously set inner HTML. It's very clear that you're doing something that is dangerous as a developer, and it reduces the likelihood of a security incident. Another really good example, I think, of a kind of default safe framework is an object relational mapper. So instead of directly interacting with a database, you use something like SQL Alchemy, and it reduces the likelihood of a SQL injection, amongst other benefits. So for us, this is really the future. Let's get people using frameworks that are safe by default, and you have to intentionally escape kind of their safety hatch or their safety mechanisms. So over the course of the talk, if you subscribe to this philosophy, I think the next question is, well, how do you actually enforce it? How do you make that change at your company or on your projects? So on one end of the spectrum, you could use grep. I think grep is actually one of the best static analysis tools there is because it works across every single language. But it's not quite expressive enough. It doesn't understand code. It understands string text. And then on the other end of the spectrum, you have more traditional static analysis tools. So those are in the SAST category. And they tend to be more complicated to work with, maybe a little bit slow. And so it's not necessarily something that you would run on every single commit, every single build, or maybe even every file save, which is really important when you're working in the development workflow. So what we found at R2C is that, hey, we really need a tool that's fast. It's got to be really easy to use. So I want to be able to extend it easily to fit the idioms of my code base. It needs to be code aware, so not just working on text. For instance, it should understand that comments are not important to the security of a piece of software. Ideally, it works across many languages. And for us, very importantly, that it's open source. So it's something that the community can use and contribute to. And that is where Semgrep comes in. And so that will this will be what I spend the bulk of my talk on, is talking about Semgrep, which is lightweight static analysis from many languages. So the idea is that you can find bug variants using patterns that are going to look a lot like source code. So we're trying to kind of sidestep having a complex domain-specific language and make something that's very simple. So maybe just take a look at the chat. Any kind of questions so far, definitely keep them coming. Awesome. So quick outline of the talk. I'm going to give you some background on the tool. Spoiler, Semgrep has actually been around for over a decade. We'll talk about grep versus tools that are able to understand an abstract syntax tree. So those are ASTs. We'll talk a little bit about static analysis. We'll do some, I'll use air quotes, pair programming, actually using the tool. And then we'll talk about, hey, so I've got this phenomenal capability. Now I want to go beyond just using the tool myself, and I actually want to install it, within CI/CD. I want to use a registry of tool checks and rules that others have already written. So we'll talk about that as well. So just to get started, there is it's a public open source project. So you can go to semgrep.dev, and that will redirect you to our GitHub project. And we love getting issues. We try to be very responsive to them, and we'd also love your contribution. So Semgrep was originally created in about 2009, and it was actually called sgrep, or PIF. And this was a project that was started by someone named Johan Padalou at Facebook. And Facebook was using this mostly with PHP and with Hack. And they used it to write somewhere around 1,000 rules to get developers onto that paved road. We're really fortunate that Johan, who was the creator of it, actually joined R2C last year. And while he was at Facebook, he was able to get the project to be part of Facebook's open source initiative. And the project was not active, and so we've revitalized it over the last year and started to really extend its functionality from PHP to many modern languages. So Python, Go, we're working on Ruby, we've got Java, things like that. And the tool, even though it started in 2009, it's kind of, I guess, genesis. If you look at kind of its lineage, its genesis comes from Cosinel, which was a tool still used actually today in the Linux kernel for finding bugs and doing refactors, automatic refactors. So the concepts have been around for a long time. Languages that we support right now, so Python, JavaScript, Go, Java, C. Ruby should land soon. So if you're interested in Ruby, we're starting to work with early users to do bug testing there and get it working 100%. And then next up is TypeScript, and we've also been thinking about adding PHP support back. And just to clarify, Semgrep as a product or as a project is open source. So you can check that out on semgrep.dev. Awesome. Any questions about the background or history of the project? Maybe I'll ask, has anyone heard about Cosinel before for the Linux kernel? Just a super cool project for people who want to geek out about static analysis. Okay, as I wait for questions to come in. So let's quickly talk about grep versus abstract syntax trees. And one of my favorite comics, XKCD, has a little vignette about this. If you're using regex, almost certainly you're going to be introducing some problems. So it's a very fragile, fickle friend. And the reason for it, when you use, I guess, grep on code bases, is that grep understands strings, and code is not fundamentally a string. Code is a tree. And so this is where we start to get into the conversation of a string versus an abstract syntax tree. So for us, if you're operating on a string, you'll end up getting basically just like false positives. So imagine that you're writing a grep, I guess, pattern, and in the process of doing that, how would you deal with in Python import aliasing, or how would you deal with new lines in white space, or comments, things like that. So there's lots of I guess aspects of the code that you write that don't matter for the functionality of the code, but would matter to a tool like grep. And so that gets very complicated, just basically very cumbersome to use and actually make sure that you're catching all of the cases you think you're catching. So on the flip side, we can turn to a tree. And this is basically the way that most tools work. When I say most tools, in my mind, I'm thinking of Bandit or dlint or ESLint or Flake8. If you're in the Go world, maybe GoLint or GoSec. Ruby, you've got Ruacop. So all of these tools are operating on that tree. And while you can customize these tools, I think the trouble is that you have to become an expert in every tree syntax for the languages your team uses. So if you are working at a company or working on projects that are multilingual, you've got to go learn a new tool every time you want to try to support or write a pattern for a new language. So the other issue is that you tend to need programming language expertise to really develop a rule or a check effectively. And this is really just because languages, generally there's more than one way to do it within any given language. And so you have to have knowledge of what we would call equivalences. And I'll talk a little bit later about how Semgrep tries to handle equivalences so that you don't have to think about it. And of course, on the tree matching side, this is where commercial tools come into play. So for us, actually, I'm a fan of a number of commercial tools, but generally to customize them, I found them to be complicated, slow. They're not always CI friendly. They're running on the orders of many minutes, not seconds, and they tend to be expensive. So one example that I want to show you, this is coming from ESLint. If I want to try to detect the use of eval, I end up with a 307-line rule to do so. So I just want to click through and actually show you what this looks like real quick. So this is, by the way, no commentary on the quality of this rule. So I think actually eval is one of the great checks that ESLint provides. The problem is that if you were to go through and you think to yourself, okay, I want to make sure that people don't use eval in a JavaScript code base. When you use a tool that's doing AST matching, you have to translate in your mind from what the code looks like to what the tree looks like. So you get a lot of stuff like this where you'd say, okay, if node type is member expression and node computed is a constant, so suddenly we're pretty far away from something that actually looks like the source code I'm trying to match. And so that's one of the things that Semgrep is going to try to sidestep. I'm just going to take a quick moment just to look through the questions. So we've talked about C# support, and actually I'd love to follow up. There was a question from Ricardo on that. Other languages we've been thinking about recently. So I mentioned that we're working on TypeScript, we're working on Ruby, and we've gotten a few C# and C++ requests. So there is C support already, and there is some C++ support, but I would say it's kind of like alpha stage. So if you're interested in playing around with that, we can catch up after. Cool. So just to kind of frame the conversation, there was a really nice article that was written by Benjamin Woodruff at Instagram. So Instagram wrote this piece, Static Analysis at Scale. And they had the diagram where, on the one side, on the left-hand side, we've got kind of easy but dumb, I'll use air quotes, static analysis. And that's just using regexes to try to find patterns. Maybe you would say, hey, this is more linting. This isn't really that sophisticated, so it's more of a lint. On the right-hand side, we have very powerful but complex static analysis. And that tends to be whole program analysis. So you're not just looking at one file, you're looking at all of the files, and you might be doing stuff like, complex data flow, kind of source and sync. Is there ever a case where user input can make it to a database? So you're doing this kind of very long tree traversal with the entire program. So for us, Semgrep fits somewhere in the middle. So we want to be as simple to write or as quick to write as something that is regex based, but we also want some of that power and some of the complexity of whole program analysis. But our kind of main charter is that it's got to be really, really fast. So I think what I want to actually do is just jump into demos. And my thought for the next probably like 20, 30 minutes is just to walk through how I would actually use the tool. I'll introduce you to its core concepts, and then we can talk about kind of some of its advanced features and where the project is going. So if at any point you have questions, let me know, and I'm happy to pause. So let me switch over, and what I'm actually going to do is just show you quickly kind of the, I guess, website that I would go to if I were going to write a rule. And let me know too in the comments if I need to zoom in, if this is large enough for you. So we have semgrep.dev, which is just a redirect to our GitHub repository. And then what we've built kind of in addition to that is something that we call semgrep.live. And the .live website is kind of a combination of two things. So the first thing is that it's a registry for Semgrep rules. So we've got a bunch of people who are writing rules and contributing them to this registry. So we've got things for Django. We've actually ported a bunch of GoSec. There's a great tool for JavaScript called Node.js Scan that now uses Semgrep as its underlying engine. So we've got rules for that. The second thing is, as we were writing rules ourselves, we realized that we wanted a specialized editor. So kind of what's the workflow for actually writing a rule? So we have this nice big button here, write your own rules, and that takes us to the editor. And the editor is the main place that I'm going to be spending my time over the course of this talk. So just to quickly walk you through what we're looking at here. In the upper left-hand corner, I've got my pattern box. So this is where I'm going to write the pattern or write my rule. The lower left-hand corner, I have my code snippet. So this is sample code that I'm going to try to match against. And then we've got some other options. So if there is a match, if I actually detect a pattern using my rule, it'll show up here on the right-hand side. So let's go ahead and I guess just get started with our first rule. And for those who want to follow along, I encourage you to go to semgrep.live. I'm actually going to just be using a bunch of the examples here. So there's this button here, load examples. There's a whole bunch of examples that we have so that you can learn about the tool. And I'm going to be using mostly these. So the first example I want to use is one that shows the difference or highlights the difference between grep and Semgrep. So I have a little bit of JavaScript here, and I'm just going to search for the use of exec. Now, what's interesting about this code snippet is this is all valid JavaScript, but you can see that we've introduced some white spaces. So that's going to be tricky for grep to find. We've got some multi-line examples, which is also going to be tricky for grep. Some commented out code, and just some comments, so console.log. So some of these examples, if I'm doing a quick audit of my code base for calls to exec, I don't care about. Primarily, I don't care about commented out code, and I don't care about strings that have the word exec in them. So with Semgrep, the way that I generally approach it is actually just copy and paste code. So let me just copy and paste exec ls, and I just want to see if it actually matches anything. So immediately, my pattern looks like the code I want to match, and I have a single match. But what I really like to do is say, hey, I actually want to find all calls to exec. And so we're going to come to the first kind of core concept of Semgrep, which is what we call the ellipsis operator. So ellipsis is just 3 dots. This is very similar to using dot star in a regular expression. And it's just a way for me to kind of abstract away the details. So I want to call to exec, but I don't care what its arguments are. So I'm just going to run with this pattern. And we'll quickly see that I actually find all of the calls to exec in my code snippet. Important, I think, concept in Semgrep is that the pattern that I'm writing has to be valid source code. So I can't leave off a parenthesis, and I have to follow any other conventions, I guess, of the language. So it needs to be parsable into source code. So that's the kind of the first concept. I think quite simple. So let's take it a little bit further. So notice I'm in JavaScript here, and I'm just kind of copying what looks like JavaScript code. I'm going to switch now to a Python example. So the Python example that I'm going to switch to is the use of Bodo 3. So this is the AWS client Python, I guess Python library. And in this example, what I'm going to try to do is find hard-coded strings. So the use of Bodo 3 client, where someone has hard-coded AWS, the AWS access key and the AWS secret access key. So kind of following the convention I said before, I really like to just copy and paste code in. So I'm just going to do that. And in this case, we're going to come back and use this ellipsis operator. So I don't care what this first argument is, but I do care about these access keys. So what I'm going to say is, find me all the places where there's a hard-coded access key. So it's a string literal, but I don't care what the contents of that string are. And I'll just go ahead and run this. And it's going to match both of the cases that I have below. Now, the subtle thing, and this is where kind of earlier I was talking about, oh, you have to be an expert if you're doing a AST matcher, or like a tree matching. You have to be an expert in the idioms of that language. So because we're in Python, if you're using keyword arguments like access key and secret access key, it doesn't matter what the order of those keyword arguments are. And so in this case, even though I have access key before secret access key, I'm matching a case where those two are reversed. And so this is just like some of that extra kind of wind in your sails that Semgrep is going to give you when you're writing patterns, because it understands that in Python, this order does not matter, and therefore I should match kind of regardless of what the code is written as. Any questions about the ellipsis operator before I introduce the second and last major concept in Semgrep? So feel free to pop those in. I think there's a little bit of a delay. I'm going to move on to the next example, and if there are any questions, I can always pop back. Okay, so on to the, I guess, last core concept. Beyond having the ellipsis operator, we have something that we call meta variables. And meta variables work a lot like capture groups in regex. So the way that you note them is you just do a $, and you follow that $, with a capital alphanumeric character. So I can do $x equals $y. And in Python, what this is checking for is it's just going to say I have an equality, operator, and there is some expression on the left, and there's some expression on the right. Find me all the places where that's true. A quick note is that the ellipsis operator and these meta variables are greedy, so they'll try to match as much as possible. And I'm just going to run on some snippets down here, so you can see, very quickly, anywhere where there's an equality, we have a match. So just identifying where these equalities are, maybe not so interesting. What's a little bit more interesting is that the capture groups are actually can be reused. So I could find all places where what's on the left-hand side of equals matches what's on the right-hand side. And you can see just kind of ahead of time that I've got a few examples here where, if cat equals cat, something a little bit more complex. So this is, a concatenation, string concatenation. So hopefully that will match. And then there's one more subtle example. I'll just go ahead and run this. Down on line 12, which is probably the most interesting. This is an actual bug from the Apache libcloud project where they were trying to use node _ID, but instead in their equality operator, they just repeated x dot node ID. So I think what they had originally intended was actually to do a match like that. So we've been using this to find, usually it's just typos, particularly when variable names are very similar. They have an underscore, or they have a dot, but it just kind of quickly shows you what the meta variable concept is. So one question from Andres: how do you search for the string dot dot dot? That's a great question. I don't recall offhand how to escape the dot dot dot. I know you can, so I'll have to look that up in the documentation afterwards. But I have not had to find that string yet, so I appreciate the edge case. Any questions from the group on this meta variable concept? Cool. So let's go ahead and, I know I told you there were only two main concepts. I want to show you now how you can combine these concepts to get a powerful pattern that's going to find, I would argue, like kind of real bugs. So something that you might want to deploy in CI/CD. So I'm in Python. I'm showing a lot of Python examples because it's what I primarily program in. And in Python, specifically when you're using Flask, there is a call called setCookie that by default is not secure. So this was a great example of, I want to make sure that I'm going to get developers and for myself using this function call safely. So let's get someone onto that paved road. So what I want to first just start off on is finding calls to flask.response.setCookie. And I just want to find all calls in this snippet that look like this. And something you'll note is that I actually have the fully qualified name here. So later on in my snippet, you can see I've got some aliasing. So from Flask, import response is R, and I make a call to r.setCookie. Semgrep is going to resolve this behind the scenes, and I'll need to use the fully qualified name for that function. So in this case, it's got the main library, the class, and then the actual method. So let's just go ahead and run that. Cool. So this finds a number of places where setCookie is used. And I was saying that, hey, setCookie is not secure by default. And what I meant by that is, in this last example, you want to set secure equals to true, HTTP only equal to true, and you probably want to set same site equal to lax. So now I'm in a mode where I've got some examples that don't do that. And I want to only match, for example, this like setCookie hello world. But I want to exclude calls that use secure equals true and HTTP only equals true. So for that, for those who've been poking around, you may have noticed that there's this tab up here that says multi-pattern YAML. So we're just going to click over to that. And now we introduce basically this YAML syntax that supports Boolean composition of patterns. And there's a bunch of documentation that we have on this. So if you go to, I'm on the Semgrep repository right here, and I popped into the documentation. So there's a whole bunch of operators here that we can use. So I can define a single pattern. I can define multiple patterns. We get into like oring and anding. So like pattern either, not, so pattern not. And there's a lot of basically fine grain controls here to make sure that we're getting true positives, and I can actually give a good recommendation to the person who has just tried to use setCookie incorrectly. So a quick example of that, we're just going to focus on this patterns key. So there's some other kind of fluff around it, like I have a nice ID, I've got a nice helpful message that's going to print out for the person who's running Semgrep. And under patterns, I kind of told you before that I want to find all the places where we use setCookie, but I don't want to match on places, so this is pattern not, where HTTP only equals true and secure equals true. And you'll notice that there's a use of ellipsis here before and after. And that's just saying, hey, I don't, again, care about kind of what precedes these keyword arguments, and I don't care about what happens after them. So if I just go ahead and run this, we'll see that we don't match on the example that was good. So this cookie is secure, and we're letting that go by. We're not flagging it. but we are flagging the examples where those flags are not correctly used. So this is really, you can use like the simple patterns that I showed you before for like a quick audit. We have a command line. You run this on your command line. You can brew install it or pip install it. So I'll use the command line tool for these quick audits. And there's just like a -e or -pattern flag. So you can do kind of nice, simple little searches. And then once I actually want to write a rule, then I'll usually flip over to something like semgrep.live, and I'll use the YAML syntax to express all the cases that I don't want it to match, I do want it to match. And there's some really nice testing that's built in. So I don't have it on this example, but there's actually the ability to add test cases in here and get some indication of coverage or success. So very quickly, we just introduced that, hey, there's this YAML syntax, and you can use it to write more complex rules. Are there any kind of questions about that? We've covered a lot of ground now between the ellipsis operator, those meta variables, and now the YAML syntax. Awesome. And what we're going to do is now we're just going to reuse those three concepts over and over for the rest of the presentation. Cool. Okay. So I guess I'm kind of now getting into like, what are my favorite parts of Semgrep? We've tried to take the Unix philosophy of doing one thing well. So that's identifying code patterns. And kind of on top of that, we really believe in composability. So we know that there are tools and approaches that people already take that we want to support. So one example of that, early in the presentation, I talked about grep being an amazing static analysis tool. What would it look like if you combined Semgrep with grep? And we have a pattern that you can use for that. So in the YAML syntax, the code snippet I have down here is, again, calls to boto3. Let me just go ahead and clear this out. So I've got calls to boto3 client, and the host is being defined. So what I'd like to do on my first pass is just an audit of this to find all the places where boto3 is used and host is explicitly set to a string. So I can just run that. We'll get the two matches. And that's because of my pattern up top. So I have boto3.client host, and it's equal to that string with the ellipsis operator in it. So now I want to get into the refinement mode, where what I really want to do is I want to find all of the uses of this library where the host is an internal network. So what I can do is I'm going to go ahead and just change this pattern a little bit. I'm going to use the combination of something called pattern inside and pattern regex. So pattern inside works largely like a filter for later patterns. So what I'm going to start with is find me all the places where boto3 client is used, host is set to a string, and then within those matches, so this is like the range has been reduced, I want to find places where this string appears. So pattern regex will match actually anywhere within that range. And in this case, I've defined what my internal IP is. So 192 dot, just the classic, 3 digits, 1 to 3 digits, period, 1 to 3 digits, period, 1 to 3 digits. So it's a little bit of a nasty looking regex, but it's just going to search for kind of this pattern. And I can go ahead and, again, run that. And now we're getting a much more restricted match, where we are only matching on the first case and specifically the string within that first case. So something that I struggled with when I first started writing Semgrep rules was kind of understanding how is this filtering working. There's this Boolean composition, so like what's matching. And I find myself sometimes I'll get to the end of writing a rule that I think should work, because my code should always work the first time I write it, and it doesn't match anything. I'm like, it's just like it's hard to reason about. So one of the reasons why I'm showing you this live editor and pushing you towards the live editor is because we've done a bunch of work to make it easier to do development. So specifically, over in the matches column, there's this little button I can click that is show steps. And it's going to show me the process that Semgrep went through to identify this match on line 2. So I'll just do show steps real quick. And what's really nice is that I can look at the kind of the patterns that I'm using here are a little bit, they're just given kind of like temporary names like .0, .1. So I happen to know that this step number 1 is looking at patterns key, and there are 2 patterns within it, pattern inside and pattern regex. And so we're finding all of the matches to those different patterns. So this is kind of the aggregate of all the patterns. You can see I can highlight those. So if I'm looking at pattern inside, the first thing that's going to happen is that I can look at pattern inside, and I can see all the places where basically I'm going to select from boto3.client, host equals. So this is just very helpful to know, okay, I see that I have those matches for my very first pattern. I know that pattern regex is only matching on this 192.168 string. And then the final step brings them all together, and I only get 1 match, which ends up being the pattern regex. So this is just like a nice way to get a little bit of insight into, hey, what's the process when I write a rule? Why am I not getting a match? And you can debug that and figure out why your rule at any given stage may not be working. So definitely recommend that and recommend the live editor for it. Cool. Yeah, before I pop into kind of a more complicated business logic example, any questions? Maybe I can at least get a thumbs up from everybody that this makes sense so far, just so I make sure that I'm not moving too quickly. Sweet. So onto the home stretch. I think there's just kind of 2 more examples that I want to show you. So we've mostly been looking at security related things, either boto3 and hard-coded credentials, or the incorrect use of Flask's set cookie function. So what if I wanted to do something that was more business logic-y? So I have a bit of sample code here, and this is under the examples, by the way. So if you want, this is the call this before that example. What we're looking at here is kind of hypothetical. I have a financial application that I've written, and the way that it's architected, anytime there's a transaction that I'm managing, I need to verify the transaction before I call make transaction. So it's a this before that type of sequence. And I want to make sure that people always do this. So if verify doesn't occur before make, then something is wrong. So in this case, again, going back to that composition, Boolean composition, I'm going to identify the pattern that I'm trying to look for. So again, it has to be valid Java code this time. So now we're into the Java world. I'm looking for public methods. I don't care about what the return is. So I'm just using a meta variable here as a quick way to say, hey, I don't care. Method call, I don't care about what its arguments are. I actually don't care what code precedes make transaction, and I don't care about what code comes after it. So here are calls to make transaction. So I want to find all the matches to this. But if verified transaction, so this is pattern not, if verified transaction occurs before make, then we're fine. Don't fire. So this is a very quick way to encode some of this business logic. And I'll go ahead and run this. And by the magic of demos, it finds things that are bad. So here's a call, no verify is used. So we're missing our verification step. It looks like somebody typoed here and made the transaction before they verified it. So that's not very good. Because we have this ellipsis in here and we've ignored content that comes before, content that comes after, or code that comes before or after, the fact that we have all these system.outs doesn't matter. So in this case, again, it looks like someone called make before they called verified. So that's bad. So I just want to skip to the end. And there is a false negative here. So a case that we missed. And I want to talk about why we missed it. So at first glance, this last example, I do call verify and then I do call make. So hey, that seems like that's okay. Except what I am verifying is not the transaction that I'm making. So this seems like a bug in my code. This is actually something that I want to detect. And the reason why I'm not detecting it is because I used in verifying make here an ellipsis operator. And I said, I don't care what the arguments are. But in fact, I do. I actually want to make sure that the same argument is used in both cases. So this is a very simple change. I'm just going to add in $T. So I mentioned before that for meta variables, their quality is actually maintained across the pattern, which lets you say, I want to make sure I'm verifying and making the same transaction. And with that change, I actually detect this last case now. So that's just a kind of quick example of business logic. Some kind of cool alternative applications. So I won't dive into this example too much. I mentioned that Semgrep is a tool that follows the Unix philosophy, so it's meant to be very composable. One of the really neat things about it, it's got JSON output, so you can add it to your kind of own pipeline, your own tool chain. This was an example that one of my colleagues wrote. So I've got actually two colleagues. So one, Clint Gibbler, if you've ever read TLDR-Sec, so he's the author of that, maintains that. Really, really good, great newsletter. So recommend everybody follow that. And another colleague of mine, Matt Schwager, who is the author of DLint. So he used to be at Duo. He wrote effectively a replacement for Bandit called DLint, and now he's very fortunate to work with him. So they've been doing this work where they've been using Semgrep to do what we've been calling kind of code inventory. So we want to understand the shape of a project. You know, what are the routes, the endpoints that are made available? What are the permissions on those endpoints, things like that. So what they did is they used Semgrep to extract these patterns where, again, we're in the Java world. And what they wanted to do is they wanted to extract out annotations like request mapping, annotations like authorize, and understand what's happening. So in the messages that you print out, if you use a meta variable, we'll actually populate that meta variable with the value that is captured. So if you think about capture groups, we're effectively saying print out the capture group called method, called path, called HTTP method, and authc. So what they'll do is they'll use Semgrep. They'll write these patterns. They'll extract information in this very specific format, and then they'll use that in a later stage of their kind of pipeline to show all of the routes that are within a project. So I'll show you a visualization in a minute. But this is just to kind of try to reframe, hey, you don't need to use Semgrep just to enforce at CI time, some kind of like paved road expectation. You can actually use it for security assessment of a project. And routes are one of the, I think, actually biggest use cases that I've seen where you're not actually necessarily putting it in front of the developer, but you're using it for a security audit or maybe even pen testing. And I just want to show you. So they ran this on a bunch of projects. And if I just pop back, they then produce these tree visualizations, which show you at the end here all of these nodes show me all the endpoints that a file defines, and they color code it based off of its what permissions it's been given. So is it an admin endpoint? Is it authenticated or unauthenticated? And this makes it really quick to go through and realize that maybe someone actually forgot to authenticate an endpoint. So really, really cool use case, and just something like that's very different that you can do with Semgrep. So final few things that I'll mention. That's basically actually it for rule writing. We covered a lot of ground. Any questions from the group before I switch over to just briefly touching on, hey, if you want to use this thing in CI or if you want to use the CLI? Cool. So what I'll show you is just very quickly the registry. So I was on semgrep.live again, which we kind of talked about. This is like the main place that I personally go. And previously, we chose the write your own rules path. So this time I'm going to choose use community rules. And what we have here is a number of rule packs that either we've contributed so far or members of the community have contributed that you can run quite quickly and easily. So I just want to double click on, we'll just do the Python rule pack. And so quickly I can see how many rules are in this thing. So there's 22 that are in there. I can explore what the rules actually are. So I can click and take a look at the references for it. I can look at what the message is going to be. So this is just a set of kind of general checks for Python. And what we try to do is always show you what the pattern is. So if you're looking to kind of improve a rule, you can actually look at an existing one, And then you can say, hey, you know what, like I want to open this in the live editor. So this will just open up in the live editor. And now you can tinker around with the rule and with the test cases. So you can see there's a little bit of annotation here, OK, and rule ID. And you'll actually get a all test pass indication on the live editor. So yeah, this is kind of just like looking at this overall check pack. What I really want to do is I want to run on my own personal code. And I think in order to do that, I actually have to show my entire screen. So let me just quickly switch over to show my entire screen here. OK. So what I can do is just click to copy real quick. I already have Semgrep installed locally. So I can just do, just to show you. Just to prove I got semgrep-help. So there's a whole bunch of options here. But what I can do is just run semgrep-config, provide it a rule pack URL, and it'll download it and then run it. So it just ran 27 rules and gives you a little progress bar. And I very thankfully, my personal project don't have any violations. So very easy to get going with. I think I mentioned before that there was a pattern syntax. So if you want to quickly just do patterns here, if I was looking for like exec before, I could have done something like this, semgrep-e, exec, and then specified a file that I wanted to check. So a lot of capability there on the local tool, and really nice that I can actually go through and basically benefit from the community's work. So if you're using Django, I think I mentioned briefly earlier, we've ported a lot of the GoSec rules to use Semgrep, so you can just use GoSec. If you're in the Java world, actually this one's really cool. So Semgrep doesn't work on a binary or compiled code, it works on the source code. So we've ported, I think, nearly all of the findsec bugs checks. So if you're using Java, findsec bugs is a pretty common tool for static analysis. But we're running on pre-compiled code, so just that source code. So you don't have to worry about the build system, how do I get the project to compile, any of that. You can just run findsec bugs on the raw source code, and that's actually, for me, it's been a game changer because it's such a pain in the butt in Java to figure out someone's build system and add this stuff to CI. So it makes it just much, much easier. So you can go through and explore that stuff. And then the kind of last thing I'll just mention is that all of the rules are public. So you can go through and filter by what language you're interested in, what category of check you're interested in. And you can actually create your own rule pack here and just pick the things that are relevant to you. So it kind of builds up my little cart. And then I can so-called checkout. We're still working on this part of the flow, but you can check out with your custom rule pack, get a URL, and move on from there. Similarly, if you are using the CLI, if you write a rule, you can always go and click on Run Locally, and this will give you options for actually running your rule locally. So it's very easy to work on something on the editor and then get it to run on your local machine. Okay, I think that's basically it. We've got a number of integrations. So we've got a GitHub action and pre-commit hooks. So those are really neat if you're looking to get started. We actually work with GitLab now as well. And because we've taken the Unix philosophy, if you've got Perforce or if you're on Concourse or some other system, it's pretty easy to get started with. Features that are coming up. So I think I already mentioned, but we are adding new language support for Ruby and TypeScript, amongst others. So let us know what you're interested in. And we're also integrating typing information. So I think with that, I could just take questions.
Cool. So let's wait if some questions arise. I have a couple of questions myself, actually. So can you give any information about the expected performance?
Yeah, that's a great question. So we're targeting, I'm just trying to think back to what our performance target was. I think it's 100,000 lines of code per second for any given rule. So this is a little bit hard because for more complex rules, they will take longer. And for a rule pack, if you're running, let's say 50 rules versus one, there's some performance hit there that you take. We've done a lot of work so that Semgrep will run these rules in parallel. It tries to take full advantage of your CPU. And I would say, like, kind of on average, I find that I'm getting, a couple seconds for, well, basically, like, we'll say like a second or 2 seconds for a few files. And if you're doing the entire project, it could take, 30 to 60 seconds. And generally, I would push that type of analysis to CI time when the time constraint is less.
Okay, and given that you're working on the source code level, there's no time needed for compiling stuff, or?
Correct. Yeah. So there is time that's required for parsing, but we're clever that we will cache parse code. So we'll try to reuse as much as possible so that we're not parsing every single time if the file hasn't changed.
Another question is, you mentioned that you're using the AST. Are you doing any sort of transformation on the AST? For example, like string concatenation, something, so that more patterns get matched?
Yeah, so we are kind of going back to equivalences. There's basically everything gets built into a generic or universal AST, but then there are kind of a layer below that specializations for each language. So we'll add a language, we'll define what its equivalences are, and then I guess we're trying to operate a pattern on this universal AST. As a result of having to basically parse each language differently and figure out its equivalences, historically it was time consuming to add a new language. So right now we're most of the way through a project that changes the underlying parsing system to something called Tree Sitter, which is a GitHub project, or project from GitHub. And that will make it much faster to add languages because they already do the underlying parsing, and then we can do a little bit of light customization on top.
Ah, very nice. The whole project looks very, very polished, to be honest. So that's
hopefully not too polished. I want it to work well for you, but understand it doesn't need to be too pretty yet. So
yeah, we have 2 questions by group users. So one question was, can we download the rules to run locally?
Yes. Yeah. So you absolutely can download the rules to run locally. Kind of a few options there. You can actually just curl that checkpack URL, and you'll just get a YAML file like it's downloaded. So that's quite simple. And you can also set Semgrep up to run local YAML files. So if you write your own, your own snippets, you don't want to publish them publicly, you can just create a YAML file locally and point Semgrep to that.
Nice. And another question was about how you deal with false positives. Is there a way of marking false positives between runs? So.
Yep. So yeah, that's a great question. So kind of 2 approaches that we take there. The first approach, you can add a comment to suppress a result. So we use the comment nosem, N-O-S-E-M, and that will suppress a result for a particular run. The other thing that we do if you go and you use our GitHub action or our GitLab action, the results that we show you, the results that we would fail a build on, are only the results that have been introduced in that branch or in that pull request. So we'll effectively we'll do some clever filtering so that you only see stuff that you've introduced.
Yes, so you create a diff on the branch already. Nice.
Yep, exactly. So it's not quite dealing with false positives, but it means that you won't have to deal with other people's introductions. So.
Nicely put. And I saw the Add to CI button on in Semgrep Live. What is that button doing?
Let me go and see which button.
On the bottom, the 3rd button, Add to CI. Is this?
Oh yes. So that's a great question. That will give you instructions for adding your specific rule or a rule pack to CI. So we have a bunch of boilerplate. If you're using Circle CI or Travis or GitHub Actions, we'll help you get started really quickly with that.
Again, very polished.
I'm going for simple. I wanted to. I'm hoping that this is very, very easy for people to get started with. I appreciate the compliment.
So, do we have any more questions?
I have a question for the group. I'm curious if people are using grep at all, or any of the static analysis tools that I mentioned. yeah, and if this seems interesting to you.
So, as I'm still not unmuted, so I think both use cases very interesting. So just grepping over source code to find some common bugs. Maybe would be great if there's something like a library matched to the OWASP top 10 or something, like those are common errors for that and that. I mean, actually, those are your example packs already, I think.
Yep.
And then I think integrating that into CI/CD might be interesting, especially if it's more agile or lightweight than a full-blown SaaS solution.
Yeah, and the idea is, it's not going to capture everything. So it's not whole program analysis. It's on a single file, but we found that it's really, because it's fast, it's much easier to integrate. And basically, it's, for us at least, it's been good enough. Oh yeah, so I see that there's a question, or just a mention of Bandit. I think we're actually in the process of porting Bandit over as well, Ricardo. If that hasn't already landed, it's actively in progress. So we're trying to reduce our use of other SaaS tools just for our projects. And so a lot of the Bandit checks we're actually moving over right now. So hopefully that makes it easier for you.
Cool. Okay, then with that, I think it's up to me to say thank you. It was a really cool presentation. I'm going to try the tool.
Yeah, thank you, everyone. I really appreciate all your time. If you have any questions, I'm happy to stick around. We've got a Slack room that people can join, so I'll just throw up that slide. And we'd love to see you around the community. And
just to mention, the presentation has already been uploaded as comment to the meetup group, so you can see it also there, or a link to the presentation at least. Cool.